Okay, in this podcast we're going to learn how to balance half reaction equations or balance redox equations using the half reaction method. Now these are in this set of instructions, and the problems I'm going to do are on page 2 of the worksheet packet. Now these get a little bit more complicated than the ones that we did in Honors Chem. Actually, I should say quite a bit more complicated. And can seem very confusing at first and difficult to do until you've done enough of them that it becomes second nature. So what you want to do is refer to this instruction sheet, which takes you step by step, and the steps will be natural after you've done enough of them, and use them to balance the equations. Now, it doesn't really make sense to go through all of these at first because you don't need all of these steps and all the equations, but you do want to start off first of all identifying those atoms that have a change in electrons and make two half reactions from them, and then we want to go ahead and balance atoms and charges, and we'll take a look at how to do that. So again, this is page 2 of your worksheet packet. So first reaction we have here is we have to identify where we have an element that's changed charge, and one place that's always easy to look is when I have a element by itself, because that's always going to be 0, and if it's an ionic compound over here, as it is here, it's a -1. So chlorine goes from -1 to Cl to 0, and because there's a 2 here, I'm going to put a 2 here. Okay, so this is 2 times -1. This is 0, so I need 2 electrons here. 2 electrons are lost. The other atom that is probably going to be the one changed is the chromium here. Whenever you have an ionic compound with a polyatomic ion, the center atom is often the one that gets changed. And if I look, I've got oxygen, each is -2, that's -14. This is +2, leaves chromium as a total +12. Each of them must be +6, and here the chromium goes to a +3. So I have chromium 2, each is +6, to a chromium +3. Because there's a 2 here, I want to go ahead and put a 2 there. And here I have 2 times +6 is 12, 2 times +3 is 6, so I need 6 electrons here. Alright, so what I want to do now is balance for electrons lost and gained. And I have 2 here and 6 here, so I need to multiply this whole equation times 3. And when I do that, I end up with 6 HCl, and I end up with 3 Cl2s here. And for the Cr2, I just have the 1, and I need to put this 2 here for the chromium chloride. And then I have to see if everything's balanced. So I have 6 H's here. And I only have 2 here. Let me see. Well, let's do the O's first, because I've got 7 O's there, so I need 7 O's here. And if I do 7 O's here, then I need 14 hydrogens. So I need this to be 14. Okay, when I do that, let's see what happens. I also have 2 K's here, so I need 2 K's here. So I've got 2 CR's, right number of O's, right number of K's. So let's see what I got for chlorines. I got 14 of them here, and here I've got 2. Here I've got 2 times 3 is 6, and here I have 3 times 2 is 6. 6, 6, 12, 14. So this looks like it's going to be balanced. Let me just see if it matches my answer key. Yep. Alright. Now I have this. Let me see. So it looks like the iron is changing, right? I go from Fe plus 2 to Fe plus 3. I need 1 electron here to make that balanced. In here, I go, manganese goes from, looks like a -8 plus 7 to to an Mn plus 2, so I'm going to need 5 electrons on this side. Okay. So this is gaining 5, this is losing 1, so I've got to balance that by putting this 5 here. Okay, I carry that up, I end up with 5 FeCl2, 5 FeCl3. So let's see what else we have. So I have 4 oxygens here and just 1 here, so I need to make that a 4. In that process I end up with 8 H2s, or 4 H2s, which is 8 H's. So my Fe is balanced. My Cl, I have 8 plus 10, and here I got 15, 16, 17, 18, so my Cl's match, my Mn matches, my O is good, so that looks like that's going to work also. Alright. Now some of these say that they're either in basic solution or acid solution. So I'm going to do the last one first, which is acidic. But let me first go back to this set of rules. So it says balance each half reaction with respect to atoms and charges. First atoms other than hydrogen and oxygen, then oxygen with water and hydrogens with H pluses, and ionic charges with electrons. Okay, so we're going to do all that, and it's a little bit, again, take some practice. Alright, so here I have, let me see, and when you have these acidic and basic ones, you end up having ions down here. So I've got 3 things going on here, and they're not all involved. So Cu is a +2 here and a +2 here, so that's not involved. So I have a sulfur -2 going to a sulfur 0, and I need 2 electrons there, right? And then I have an NO3- going to an NO, and this is where I don't just write the element, I write the whole thing. Okay, and this is what they mean when they say balance the oxygens with water. So I have 3 oxygens here and 1 oxygen here, so to get 2 more oxygens here I need to add water. That's the rule, you add water. Okay, so I've added 2 oxygens, so my oxygens are balanced, but now I've added 2 H2s, which I will balance over here. This is acidic, so I'm going to balance it with H pluses, right? 2 times 2 is 4 hydrogens. Okay, so now I look at my electrons for this one, and here I have a +4 -1, that's a +3 charge. This is all neutral, so I need a 3 electrons. Okay. Now I have 3 electrons in this equation, 2 electrons in this, so I need to multiply this times 3. And when I do that, I end up with 3. Cu and S are both going to end up with 3, right? And I multiply this times 2. When I do that, I end up with 2 times 4 H pluses. I got to add that in here. 8 H pluses, okay, plus 2 NO3s, plus 2 NOs, plus these 2 waters. Let me see. And let me see. And that looks good. Okay. Now let's go. Takes one more step. After I add the 2 half reactions, I add hydroxides on each side to neutralize the H pluses and then cancel water molecules. So let's take a look at what that looks like. Alright, so I have an S2- becoming an S0, so we need 2 electrons here, right? I have an MnO4- becoming an MnO2. 4 oxygens, 2 oxygens. I'm going to need 2 waters to get the extra 2 oxygens. I end up with 2 times 2 is 4 H's, so that's plus 4 H pluses. Okay, now when I do that, I end up with plus 3 on this side. This is 0, neutral, so I'm going to need plus 3 electrons. Now what it says to do here is, because this is basic, I want to add hydroxides to both sides to neutralize the acid. So I'm going to add plus 4 OH minus, plus 4 OH minus, and when I do that, these become 4 waters, and these, I have 2 waters and 4 OHs. So because I have waters here and waters here, I can get rid of these waters and end up with 2 waters here. Alright, so that's looks kind of messy, but I have 2 electrons here and 3 electrons here, so I need to multiply this equation by 3 and this equation by 2. So let's do that. 3 here and a 3 here. Alright, 2 comes up here. I end up with 2 waters, so this is going to be 2 times 2 is plus 4 waters. And I have 2 MnO2s, and I have 8. 2 times 4 is 8 OH minuses. Let me just make sure that matches what I have in the answer key, and in fact it does. So voila, and we're done.